now. Hello everyone, my name is Barbara and I would like to welcome you all to our latest Novedge Webinar episode. In this week's episode, Organic Surface Modeling in SolidWorks with award-winning power surfacing from nPower software. Power surfacing provides organic Class A surface modeling in SolidWorks through an innovative unification of SubD modeling and SolidWorks features. Today's presenter, Sue Blackman, is a 3D artist, author, and educator. She has taught classes in the engineering and drafting departments of top-rated community colleges and has authored for Apress, Lynda.com, and AMC Siggraph. Specializing in combining game technology with CAD data, she has been involved with the development of 3D applications, training material, and workflow analysis for well over a decade. Before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's need. Put us to the test and come visit our webpage at novedge.com. And for more daily software news and limited time promotions, pay a visit to the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, discover what's new in ZBrush for Release 7. Join us as Pixelogic's own Paul Gabourey takes us on a tour of ZBrush for Release 7. Last but not least, today's webinar is free and is being recorded live. If you want to watch this or any other webinar episodes in our collection, just head on over to Novedge's YouTube or Vimeo channels. And now, I'm going to pass the screen to David Gill from nPower, and he'll tell you a little bit more about Surface Modeler. Okay, Dave, okay. I'm gonna give you the screen. Here's your screen is all yours.
Okay, thank you, Barbara, and thank you all for attending. Can you see my screen?
We can see your screen. We see the PowerPoint screen, but not the full screen.
Okay.
Maybe you have to make... Perfect. Here we go. Enjoy the show.
Thank you all for attending, and I'm going to give a brief introduction of power surfacing before turning over the time to Sue Blackman, who will give the demo and presentation. This is about power surfacing, an industrial design product for SolidWorks. And we're very happy that the product has been chosen as the gold medal best software solution product at SolidWorks World in 2014, and again this year it was chosen by MCAD Cafe as the best software product at the show. So I'll give you a little background on why it's so popular. First of all, you might ask, why would I need power surfacing? If you struggle with freeform organic shape modeling in SolidWorks, or if you have difficulty creating tangent or curvature continuous Class A surfaces, or if you're using other software for industrial design or need to import polygonal objects into SolidWorks, then you probably need to look at power surfacing. Some of the industries that we have customers in already, and this is just an illustrative list. There's many other industries as well, but these are some of the industries that are using power surfacing effectively. Some of the background on power surfacing is that we had a product called Power SubD to NURBS for Moto. In fact, we do plugins for many other products. But that product was seen by SolidWorks employees, and those employees decided to contact us and ask us if we would put the product into SolidWorks. So we worked closely with the SolidWorks team to make sure that the product was integrated in a way that it would look and feel just like it was a SolidWorks product. So that was the goal, and we think we accomplished that goal by working closely with that team on things like icon design, on the user interface guidelines, and we did usability studies with SolidWorks customers to make sure that it was a well-integrated product, and we think we've achieved that. What it is it's we added a subdivision surface modeling tool to SolidWorks to provide organic freeform modeling inside of SolidWorks. It can convert those sub-D models into standard SolidWorks bodies, surfaces, and solids. And it automatically creates Class A surfaces, so it creates a nice, smooth, solid model automatically. It's tightly integrated with SolidWorks so that it shows up as a unified body in the feature tree, in the standard feature tree, just like any other SolidWorks feature. And like all other SolidWorks features, you can apply SolidWorks features to power surfacing objects. You can also constrain to SolidWorks surfaces, curves, and planes, just like you can with normal SolidWorks objects. And you can roll back at any time and edit those power surfacing bodies just by clicking on it in the history tree like you do normal features. And you can even edit SolidWorks surfaces as if they were power surfacing objects. So what power surfacing provides is greater productivity. It saves time and money. And for instance, one of our customers told us that on their standard projects, they went from 8 months to 6 weeks just by using power surfacing, which allowed them to go into different markets and do their product design much quicker. It provides the ability to define and design difficult shapes easily. As I mentioned, it's well integrated with the SolidWorks product, so it feels like it's standard SolidWorks. And it reduces the difficulty of modeling surfaces in SolidWorks, or as Paul McCrory has said, power surfacing is surface design for non-surfacing experts. Okay, with that brief introduction, I'd like to turn the time over to Sue Blackman, who will show the demo today.
All right, Sue, the screen will be yours in a few seconds. There you go. Here it is. Great. Sue, we can't hear you for some reason. We can see your screen, and we're waiting for you to mesmerize us with this presentation. We just can't hear your voice. Okay, there you go.
Can you hear me?
Of course we can.
Okay, I had the mute button. I thought I turned it off.
Okay, Sue.
Apologies for my lack of voice, everyone, and welcome. I'm at the kind of the tail end of a cold here, so bear with me. So I'm going to assume that a lot of you have never seen any sub-D modeling before, and those of you that have probably seen some of the other some of the competition's demos and stuff. And one thing that everyone likes to do is a detergent bottle because they're a nice organic shape and very designery. Well, you know, we're rugged individualists here, so we're going to do a gas can instead, and it shows off a lot of the same features. So this is kind of a finished one. We're not going to get quite that fancy on the demo, but I'm going to go ahead and do it from scratch. So when we start with our power surfacing, probably 90% of the time we're going to start by creating a box. And as you see here, we have the box right now, which is shown as the cage, and we have the sub-D version of it. So if you don't know anything about sub-Ds, the control mesh, the box part, is what is fed into the subdivision algorithm, and that's what makes it round. And we can work in 3 different display modes. We can work in this one, which is sub-D plus cage, or we can work in sub-D, or we can work in control mesh. The other thing you need to know is that the more segments we add to a sub-D, the closer the sub-D model becomes or gets to the control mesh. So if I added extra segments here, you can see how it starts filling out that volume much closer than it was. The only problem with this is that now you've got a lot of points to control with your basic modeling, and so that's kind of something we want to avoid whenever possible. So I'm going to put this down to 1 again, 1 on my segments. And then I'm going to accept it with our OK. And I'm going to switch over to my control mesh display here because it's kind of quicker. Although actually, now wait a minute, I've got to go back a minute. Sorry about that. I forgot to set up my size here. So I'm going to set my size up, length 10, width 6, and length 8, and I'll accept it. Then I'll switch over to my control mesh. And so I have a kind of a better feel for what the volume of this thing is that I'm going to be modeling. Now, in some of the later ones, you'll see that I use an image template to work from, but on this one, I'm just going to eyeball it. So we've got a lot of tools for controlling the modeling, and you notice our gizmo, it has move, rotate, and scale all built within it, and it can be done on several different axes at the same time. So I'm going to scale this in a little bit, and then I'm going to right-click, and I want to switch over. Right now I'm in a mode where I can choose vertices, edges, or faces. I'm going to switch over to just edge for now. And we've got an easy way to select edges. You can click on it to select it, but if you double-click, it's going to select a ring of edges. And this is especially useful because the next thing I want to do here is I want to insert some loops. So I'm going to once again use my gizmo. I could use the type in over on the left-hand side here, but I like to stay close to the model whenever possible. So I'll right-click and accept it. Then I'm going to select a couple of faces, and I could use my right-click menu and use the extrude, or I could use the extrude from our toolbar, but we've got a lot of shortcuts, and most of them begin with holding the A key down. So if I hold my A key down and pull up on the y-axis here, I get my extrude. And I'm going to go ahead and scale it in. Then I'll switch over to edge, and I'm going to pull this back to establish the front part of my gas can here. Now, I need another loop back here, and once again, I can use my A key, and as I hover an edge, you can see you get a preview of a loop that you can have. I'll click and accept that. And then I'm going to go over and once again hold my A key to extrude, and I pull this guy out, and then I'm going to rotate him into position. It is really a little bit too thick. Now, right now we're in world coordinate system, and it would make a lot more sense to scale it using local, and I can do that over in the left-hand panel. So I switch to local coordinate system. Now I've got my scale, and I can continue to move it. And then I'll go ahead and use my A key again for an extrude and rotate. And then I want to build up the back part to match it. So once again, A key, oops, pulled before I had my A key down. There we go. And you're probably wondering, okay, well, how are you going to bridge that? Well, funny you should ask, or think about it anyway. And that's because we have a lot of tools to help you with your modeling, and one of them is the bridge tool. And once again, I usually access it from the right-click menu. So I click on my bridge tool. I've got an option to add more loops, segments if I want, but I'm going to leave it at 1 and right-click to finish the command. And if we look at it from the top view, you can see that's a pretty hefty-looking handle. I know my hands won't get around it. So I'm going to double-click, just like we double-clicked to get a ring of edges. I'm going to double-click to get multiple faces. I'll double-click the other one here, and then I can just pull them in, make them a little easier for me to grip if I have to hold this gas can. All right, and I'll do the back end while I'm here as well. So we got something that looks like this so far. It's starting to look kind of like the gas can. Now's a good time to switch to SubD display. And you'll see now that the top is starting to get more reasonable, but the bottom part, because it doesn't have very many edges yet, is still a bit blobby. So I'll go ahead and add another couple of loops, edge loops, once again with my right click. This time, I've got my 2 loops. We've got the option to pinch or slide the loops as well when we add them. And I'm going to go over here and I'm going to offset this to, say, 50. And as these loops get closer to the other edges, you can see we get more of a definition of our shape. So it's getting pretty good here. Right-click to accept this. And then I want one more matching loop over here before I do the center inset. So holding my A key down again, click, and I'm ready to go. So on face mode, I'm going to select these interfaces, and I'm going to give them a hard edge. And you'll see it change at the corners a little bit, not too much. Right-click to accept, and I'm going to do an offset. So I'm doing offset, accept it, and once again, I'm going to give this one a hard edge. And now when I shrink it, you'll see what that hard edge has done. So now we get a faceted area here, well, sort of faceted. And we also support more than 100% weighted or hard edges too, which you'll see at some point later. So this is kind of the base of our gas can. So I'm going to go ahead and convert. So I click up here at the top. We'll convert it. And the next thing I'll do is I'll just do a real quick spout on it. Set myself sideways and take the front plane, make a sketch on it. I'm sure you guys are all familiar with all the easy bits. And I'm just going to start it back in here, and that looks pretty good. And then we'll go to exit sketch. Oops, I think I just floated something. That was not good. Sure, I didn't want that either. Help, how do I get out of this? Where's the close section? Anyone know? Oh, that should be up on the top. I'm doomed. Sorry about this.
There you go.
Mouse got out of hand. It wasn't me. Okay, so I'll exit the sketch, and over in the features, I'll make a plane. This is a reference. So accept, and then we'll make a sketch on this guy. And we'll just make a simple circle here, make about 1, accept, and then we'll extrude it, 1.5, accept. And now it's time to do some filleting. So this is just a SolidWorks piece here, but we're going to do some filleting on our converted SubD. So I'll go ahead and grab a couple of edges, and okay, I'm going to live dangerously. I'll grab more than a couple. I may regret this. Oops, missed it. On. Okay. We'll do our fillet, and I usually like to give this one a 0.2. Accept. And then, of course, one of my other favorite things, fillet being my favorite, is shell. So we'll go ahead and shell it. Just use the default. That should be fine. So give you a section look at it, show you that it's nicely shelled. And so there we have it. And then you could do some extra stuff. Well, except for one thing. Being female, I have the right to change my mind, and my mind decides that I really don't like this shape. Well, maybe I want to change it a little bit. So one of the nice things about Power surfacing is we can go back into our power body and our edit feature, and we can change it. So I might decide that I want to give a little more stylish edge to my handle. Maybe I want this piece a little different or something. It can match, something like that. So we can change stuff around. If you get too wide, you may have to reassign some things like fillets, but it's generally pretty good about remembering where things were. So I'm going to go ahead and convert again. And the next thing we'll be doing is something a little more complicated. So here it is, and it's retained the fillets, and there's your sort of your basic usage of SubD modeling and power surfacing. So you say, well, you know, I don't build too many gas cans in my line of work, so let's try something else. So I'm going to open something we've done here. And with this one, I've started out with some SolidWorks parts to begin with, or features actually. And then I've also used an image plane, an image sketch for my template. And I've got this one all made, and I've just got a bunch of rollbacks, so it won't take too long to get through it. But you'll get to see some of the basic things. Now, one of the things we've added in version 2 for power surfacing is the ability to constrain our SubDs to existing SolidWorks parts. And what I want to show here is I'm just going to show you kind of the basic procedure for it, and we'll start with the connection up here at the top of the body. So that means we're going to go to our creation tools and create a box, SubD box. And I'm going to accept it, and then I'm going to scale it down, move it into position. I should probably get a good sideways view here. And I'm going to rotate it into position. So what we're going to be doing is we're going to be constraining the edge to this edge here on the existing part. So first off, before I get any further, I want to select this face here and delete it. So we'll have a hole here. So selected it, right-click menu, hit the delete button. And the next thing we want to do is, if we're going to aim for this edge here, we want to make sure that these vertices are fairly close to it. So I'm going to select everything and scale it down. And they're not perfect, but they're close enough. The main thing we want to make sure of is that there's no ambiguity. If I push this thing all the way through here, it wouldn't know whether it was going to constrain to this edge of that ring or this edge. So we want to help it out and get it fairly close, but it's not crucial. So having done that, now I'm going to switch over to my Power Surfacing tab, and I want to import reference. So this is the constraint reference. So I'm going to click on this, and I'm going to select this guy right here. And you'll see that now we've got this yellow grid thing, and we'll say, yes, okay, we like that. And now I'm going to select those edges, and I'm going to double-click near an edge here. That's going to give me a ring rather than, it's going to give me a loop rather than a ring. I always get this confused. So I double-click here. I can always check down at the lower left. It says 4 edges selected. So I know I'm good. And in that same drop-down, now I've got a bunch of different options. And this time, I want to constrain my selected edges to the edge of the constraint surface. So I go constrain to edge. And there you can see it popped in here. Now if we look at it in the control mesh, we can see now that those vertices popped right onto the edge. And if we try to move any of them, they're going to stay on that edge no matter where I pull this. I'm going to undo that. And if we switch over to the SubD display, you can see that the edges have also constrained all the way around. Now if I tried to move one of these, it kind of gets crumpled looking, but as soon as I let go of the mouse button, it updates and puts it all back on that constrained edge. I'll undo that. I'll undo that since I've sort of messed it up. And at this point, we could go ahead and model the rest of the thing. Probably insert a couple of edges or something. And just model it and make it better there. Okay, rather than sit there and spend time fiddling with that, I'm going to cancel it, and I'm going to go ahead and get back to the feature tree because, oh, hang on, I shouldn't have done that either. I'm going to cancel this. Yes, I'm going to cancel it. Okay, because what I've already got one built, so I'll go ahead and reveal it here. There we go. It's much better. But you're also probably wondering, well, is it parametric? Well, the answer is yes and no. So if I went in and I selected this ring, went to the sketch, edited the sketch, and say, let's make that 1.2 or 1.25 or something, and exit the sketch. All the SolidWorks stuff updates, but the SubD doesn't yet. We could do it through the Power Surfacing menu, but that would update all constraints, and I've got quite a few in here in this whole thing, and that would take too long. But best practice is to actually go into the Power Body edit mode and update it from here. The main reason for that is because as soon as it updates, you're probably going to have to tweak the shape of everything else as well. So that's best practice, is to go in and update from there. Now that one looks a little bit more like a hyena shape, and I think I like my other one better, so I'm going to cancel out. And then we can go back and fix the ring as well. So the next part we're going to look at now is the bottom section. And what I want to show you about this is, if you've seen other SubD demos, one of the things you'll find is that they've been very carefully chosen so that the shape of the object is, what do I want to say? No, it's set up to be able to easily get the finished product with the SubD. In other words, all the edges line up in the right places to put the shapes where you want them. And that's kind of one of the challenges to SubD modeling is you can make the outside shape, but then when you start wanting to add more detail, you need to have loops in the right places to be able to move things or extrude things. And what we've done with the constraints, besides being able to constrain the edges, is we can constrain the surfaces. And this frees you up from needing to arrange your SubDs perfectly for the next step. And what I'm going to do with this one is I'm going to make 3 bodies here. I'm going to do the base. So I've got the body, the base, and then I'll have the handle. And by treating them separately, I'm totally free to put them wherever I want them and adjust their shape. So the bottom one now is a little bit more complicated than the top one. The top one was just a simple, a single surface that was circular. The bottom one now is going to have 4 different surfaces, and they've also got hard edges in between. You can see the seams. So let's reveal these and go into edit mode. And the main trick to this one is that wherever you have a hard edge on your constraint surface, you have to have an edge / vertex to meet up to it. You can have extras, but you have to have one to meet up in between. So this is a little more complicated. Also, because these were hard edges on the constraint surface, I've also made the others hard edge as well. And part of that was the design. So let's cancel out of this one. And now we're going to do the handle. So do some more reveals here. And the handle now is using a different type of constraint. Whereas the first two were constrained to an edge, this time we've got our SubD edges constrained to a surface. Now the top one, let me go ahead and get into edit mode here. That's coming. There we go. So the top one is an edge that's constrained to a single surface. That's pretty straightforward. And if I pull it around, you'll see that it looks like it's going out beyond the surface, but as soon as I let go, it'll snap back into it. There we go, like so. All right, that wasn't a terribly good move, but I'm going to undo it. But the bottom one is the interesting one because this one is an open edge of the SubD, but it's constraining over multiple surfaces. And now I can pull this guy. If I pull it down too far, we'll probably go back behind this a little bit. And it updates as soon as I let go. Pull it up here. And the main thing here is that just like the edges being tangent, so are the surfaces. So we're now tangent to the surface that we're on. I'm going to kind of put this one back here a little bit. Wait till it updates. And the other thing we've got is we don't have to stick with the default tangency. So I'm going to select a ring of faces here, and in our same drop-down, I'm going to go to Override Tangency. So in Override Tangency, I can change my angle. If I put it at 20, it dips inside. If I put it at minus 20, you'll see it pop out a bit more. So here you've got the stronger angle on the tangency. And we can also change the strength. 2 is probably as far as you'll ever want to go, so I'm going to try 1.5 on this. And what you'll see is that the tangency is pushed up further along that face. Okay, so once again, I've made some pretty nasty-looking changes. So I'm going to cancel out of the override, and then I'll cancel out of the SubD. And we're left with several separate pieces. Now what I've done is I'm going to take these edges from the SubD and create 3D sketches that I will use to trim the top and the bottom pieces, and then I'll knit them all together. So I've deleted parts in between and trimmed edges, and in the end, I end up with surface knit. Okay, so now my object is all put together, and let's check on surface here. Oh, one thing I need to do first is good time to turn off that sketch. And there we go. So you see it's all been knit together into a single piece. And at this point, you could then add more of your regular SolidWorks stuff. I've got some sketches in here ready to do all the fancy stuff, but I'm not going to bore you with that. But the other thing is, once again, don't forget we can go in and edit some of these. So I want to show you on the handle, go into Edit Feature. I'm going to show you a couple of the other new features of the 2.0 version. And the first one is, put this sideways. The first one is we now can edit with a level of detail. So I'm going to go to level of detail 2, which basically means it's got 2 subdivisions. But unlike regular subdivisions, these can be turned off and on. So I'm going to go to level 2, and then I'll select a few vertices here and pull them out and make some grips. So that gives us more power to add detail. But here's the really cool thing is I can go back down to my level 0, level of detail off, and it's going to update in a sec. And what it's going to show me is the changes I made on the higher level of detail, but now I'm back to the point where I can still choose my original geometry and move it around, making those big, smooth changes much easier to do. And it does its best to keep the relationship between the other levels additions in there. So the other thing we've got now is we've also got curvature display. This is one of our big asked for features here. And unlike the regular SolidWorks is, we can be working while this is on. So I can select things and move them and watch what my curvature is doing. So the blue is less curvature, the red is more, and I can see here what I've got going. So that's another feature that a lot of people were very excited to see. I'll cancel this. Want to say something, Dave?
I just wanted to answer the question. Someone asked if there was a student version, and yes, there is, and it is fully functional, and it costs $195.
Okay, so this is about all I'm going to do with this guy. I will show you the more finished file here. And even this finished one isn't that finished, but I had some fun with it, making other stuff on it. Oh, there you go. Now, the next thing we want to show here for you guys is another, not a new feature, but a new product, or rather an extension of the power surfacing, and that's our power surfacing RE. And I'm going to start by pulling in a scanned, well, it's a Panther that we retopoed. And we'll go ahead and you can see what it looks like. The SubD version of it, that is. And there we have it. And you can see how much detail is added to it. It's not too high poly or anything.
So we started with a scan mesh and retopologized it into this SubD mesh.
And it was a very clean scan too. If I select it all and delete it, now you can see our reference mesh here for the retopo. It's got more detail, but we could have added more to the other one. But I'm just going to show you quickly how our retopo works. And I'll start on the pause here because that's kind of a good place. So the retopo, Power Surfacing RE, has a bunch of tools. The main one we're going to use is Draw Faces. And it's in my right-click menu because I use it a lot. So I'm going to go ahead and kind of block in where we want the mesh to be. And you'll see on this one here that as we get close, it automatically finishes the face as we go. Now, if I turn this around, you're going to say, oh, wait a minute. Well, that's not, I don't see how that's close to the outside surface. Well, the vertices actually are on the outside surface. If we looked at their, got the right angle, which I'm not going to have. And we're also in the control mesh display. If I switch over, I'll right-click to finish the command right now. If we switch over to the SubD, you'll see that, well, now it's a SubD and maybe there's a little curvature, but it still isn't anywhere near the actual model. So what we've got is we've got the add interpolation function, that what it's going to do is it's going to add subdivisions and it's going to snap them all down automatically. I'm going to do add interpolation. And now you can see it's starting to get pretty reasonable. And I didn't have to make 30 million little polygons there. It's not that accurate yet because we're only using one subdivision. One thing we can do is we can turn on the distance display, and we can see where it's a little bit off. So blue means it's inside, red means it's on top. And rather than go and make more polygons myself, I'm going to say, well, let's just do another subdivision and see how it looks. So I did another subdivision, and now we've got a lot less variation from distance from the reference mesh. I'll close this guy out. So that's 2 subdivisions. You can see it's getting pretty close. If I really want a lot of detail, I could probably go up to 3 subdivisions. And you'll see it sucked down pretty nicely now. So that's basically how the power surfacing RE works. Now, I'll go ahead and cancel this. And as I said before, this is a really clean mesh. And when it, you're not always that fortunate. So the other thing we've got is we've got a bunch of tools that will help you clean up an actual scanned mesh. And I've just sort of simulated some of the problems we might have with one. I'll show you what we're starting out with, this one. So I made this little sample thing here, and obviously it's less an organic shape than, say, the panther, but not everyone is retopoing ogres and dragons and stuff. So we decided, we should have something a little bit more mechanical to show you and some of the problems you run into. Some of our customers expressed the wish that it would be a lot easier to get rid of features they didn't want from a scan. So in this one, I'll show you how we do that. So let me load up the actual file that I'm going to work on and go into our edit feature. So you might say, well, what happened to the rest of the reference mesh? Well, this is one of the important things here. And I'm going to go to the power surfacing, and I'm going to open up our selection set manager. And this is a reference mesh. So we go over here. And as you can see, I've already prepared some selection sets. I'm going to update them here. So here's all my parts. But now I can turn the ones off that I don't want my retopo mesh to stick to. So I'm going to make it a little simpler for me to work with. No, actually, that's a lot simpler. So I'm going to say, okay, well, I don't want these holes to get in the way. The little holes are pretty easy. We can go in here and we can go click, click, click. Okay, that's covered up that one. This one might be a little trickier because there will be some. This one, I'm going to go ahead and add some more segments. I just selected both these edges, and I'll add a few edges there. Right-click to select. And now we've got these guys patched up. And so now what we're going to do is we're going to add these to the reference mesh. So they actually become part of the reference mesh. So over in our Power Surfacing RE tab, I'm going to say Add to Mesh. And now, it's pretty much invisible there. Now here's a side view of this thing. So you can see now that this funny shape here has some compound curvature. And this is a little more difficult to fix, but we've got some really nice tools to help with. So I'm going to start out with a face across the hole, like so. And I can get away with, I think I want to go this direction. I can get away with adding loops one direction, but if I try to add loops the other direction, watch what happens. Actually, before I do that, I'm going to switch to, I'm going to turn on the transparency. So now you can see where the hole is. So if I try to add loops going this way, what's going to happen is, well, everybody tries to stick to a surface because that's what our retopo does. It actually drops our points on the surface. So we need to kind of back up here. So I'll cancel this, undo. And the nice thing is that we can leave these as constrained to the surface, and that's what the magenta color tells us. But we can also uncheck constrain the mesh. So that's kind of a constrain the mesh mode. So now I can go in and I can add my edges, right-click. And as you can see, well, everything was kind of straight. It still doesn't do too well as far as that surface goes, but it's the beginning of what we're going to do here. So now I can go ahead and subdivide it, and I'll do it maybe a couple of times. And before I get any further, I'm going to, I've got some vertices that are a little bit ambiguous about where they want to end up, and I want to make sure they're pushed off the surface. But now I can go through, and I don't want these to be constrained to the surface because there is no surface below them. So I'm going to select them, and from my right-click menu, this is constrained to mesh, and this is unconstrained. These we want unconstrained. So if I click off them, you can see now they're black, like a regular unconstrained vertex. Now, we still have that shape that isn't conforming very well, but at this point, I want to turn my constrain the mesh back on and tell it to update, snap vertices to reference mesh. And now you'll really be able to see what we've got here. So now these guys have come up, and these guys have stayed down where they were. You're saying, well, how do I get that curvature? Aha, we've got a tool for that. So let's select these guys. And what it's going to do is it's going to interpolate the curvature it should have from the surrounding one. So we go up to Power Surfacing, Specialized Tools, and we're going to say Curve Selected. You kind of saw it stretch out here, but the profile shows the real result here. So there we go. We've got some really nice ways to prepare a scan, excuse me, a scan, or the other thing we can do is we can use, we can make a retopo reference mesh from any other piece of geometry. It doesn't have to be a scan piece, and I'll show you that really quickly in the next one I'm going to do. So tell this one to add mesh, and there we go, ready to start the retopo. Another thing that I haven't shown you yet is that when you have an open edge on your retopo, because the vertices are going to try and stick to the surface, you can go and select them. If I pull them, they're going to stop at the edge. So it's a really nice way to get them lined up to your geometry. And if I switch this over to SubD display, you'll see that, well, we've got some rounded corners because rounding off is what SubDs do. But we can go ahead and select these guys and make them fully weighted or hard edge. And now they stick right down. One other thing I want to show you on this is I just did a subdivision here just so I can mess this up pretty badly. And I'll grab these things, move around. I think I'll go back to control mesh here. Oh yeah, that's making a mess. So if you're hand drawing these things in and you're not doing such a clean job like me, we've got a tool called SubD Smooth that lets you paint over the ones you've done, and it's going to average them out and make them a lot nicer. And it doesn't affect the edge ones either, so it's a good, safe tool to use. So those are our main tools for preparing your mesh. And how are we doing on time, Dave?
We've got about 10 minutes left. We wanted to stop for questions about now.
Okay. I've got one little thing I could show.
Why don't you go ahead and show it, because I don't see any other questions there.
Okay. All right. Let's close this guy. And I want to show this one. So this is another little sample that we kind of mess around with our retopoing. And this is a, like an architectural element or something, and maybe it was scanned in, or this one was actually built. But one of the things I wanted to show you is that there again, when you're talking about, we'll hide this guy. No, that one will be fine. Hide him. When you're talking about non-organic, and I mean this kind of looks organic, but it's got some hard edges as well. It's not like an ogre or a panther. And one of the things we can do is, I've given these edges 100% weight, and I could have done 50%, but because the actual, because the original piece had a little bit of a crease going down here, the nice thing is that we can add the crease to our retopo before it gets interpolated, and it helps it fit the model much better. If I did the add interpolation now, you see something like that, and I'm just going to convert it with one subdivision here. We'll say OK, and convert. And it'll come in with some crease on there. Once you've got a crease in there on the SolidWorks side, you can go ahead and add fillets or whatever to get the right amount of curvature you want on it. Okay, well this is going to take a while. You want to take over now, Dave?
Okay, are there any questions that anyone has out there?
No, David, I think that was all. I think everybody's mesmerized and they're taking notes and they're running to get it as we speak. I thought it was really good, and Sue is, she's a pro. There it is. Beautiful.
That is.
Well, I'd like to point out that we have a demo version that people can download and try out for themselves and get addicted to. So I encourage everyone to try it out. I think you'll find you like it quite a bit. We're happy to get feedback, too, on any types of features that you'd like to add. That's how a lot of the features get added, is our customers say, well, I love your product, but I'd like it to also do this. And so we make it do what they ask. So
that's great. So, speak up, raise your hands, and, the nPower team is listening. What a great motivation. All right. So if that's all, Sue, I'm going to take back the screen.
Okay.
Okay, and thank you so much. I think everybody can see my screen now, right? All right, so I want to thank everybody for attending from the Novedge team, and I want to let you know that our webpage, novedge.com, is where you can find nPower power surfacing and 2.0, and you can start having fun right away. The next webinar we are having next week will be What's New in ZBrush 4 Release 7. And to watch today's webinar or previous one, check out our Novedge YouTube and Vimeo channels. Our webinar playlist as webinars for every software taste. I want to thank you all again for joining us, and I want to thank the nPower team, Dave, Sue. Really exciting, fun, and entertaining webinar. Thank you again for presenting it and for giving us a great show. And have a great day, everybody. Hope to host another webinar soon. Thank you,
and
guys.
thank you all.
Yes, Dave?
I just said thank you all for attending.
Okay, then see you the next webinar. Bye, everybody.